All right, so let's go back to our Matlab fundamentals, and let's just briefly review. So, give me a color.
Blue, green.
Green. Do we have any green? Top. Who is green? There's a middle. I see green. He's trying to hide. Don't hide. This is actually very simple. Give me a vector of 3 elements. Can I get 3 elements? And 9. All right. So this is one vector, and then another green shirt. Not so many green shirts today. What is going on? I need a different color. This is kind of green. All right. I'm going to be free in the interpretation of your shirt as green. Okay. So if I want to, let's do vector B, and let's do column vector. Uh-huh.
4, 7, 3.
Is this correct for a column vector?
No.
I have to put semicolon, right? Okay. So this makes it a column vector, and this makes it a row vector. Okay. So in order to be able to multiply the two, say, can I multiply A and this B being a column vector? Can I multiply A and B? A is this. Yes. So if I do A times B, what is going to be the size of the result? One by one. So it's going to be one number. And that this one number we actually called scalar product, right? But if I do B times A, what's going to happen? It actually is. It's just going to be something really different. What's going to be the size? This is a green shirt. I'm going to interpret this as green. It's going to be a 3 by 3, so it's going to be a matrix. So both these vectors are actually matrices, so matrix multiplications rules apply. And one thing that we obviously see is that A times B is not the same as B times A. Okay? So you have to be careful with sizes and dimensions. Now if I wanted to save this, so let's say that this is some important data that I actually want to share with others. Now if this somebody is in this class and they know they have access to Matlab and they know some Matlab fundamentals, the simplest way to save the data is to use what? It's actually save. Diary is just going to be a text that I'm typing in, so that's not necessarily saving data. It is a way of saving data. But if I just want to save A and B, okay, I could give it a name, and I say what to save.
So you have to type dot.
Math, you don't have to actually. It's going to be just fine if you don't, and it's going to add dot math. I do because I'm old school. I type in everything. But it's actually going to just put it itself. Okay, so it's a Matlab file. So this is a very specific Matlab file. So I can actually now clear everything. So you can see that my workspace is now clean. If I ask for A, there's no A. Okay. And if I load AB, I'm actually going to get A and B back in my workspace. So this is kind of cool. Matlab actually takes care of everything. Whatever variables I might have, they're going to be stored and they're going to be loaded precisely as I stored them. Okay. But my colleague might not have Matlab. Okay. So if I want to save data more generally, then I have to go to some format that is easily readable by everybody. So this math or the easy way won't work. So I could possibly try to do, let's say we can just save A. I'm going to just save A into a.txt, which is text. And I'm going to let Matlab know that I want to save it as a text file because I know everybody has a text editor on their computer so they can open it, right? So the way to tell it to is to say -ASCII. So this is the rule for text files.
What's the -ASCII do again?
It forces a text file. So that's a file that is you can open with a text editor. And you can actually check that text files you can type. So you can say type. And there it is. This is what was written in that text file. And I can actually load that file too. I'm just going to say load a.txt. And my data is loaded as 359. Yes?
So if you don't put the -ASCII on there, it won't save it correctly?
It won't save it as a text file that I can read in a text editor. So everybody has a text editor on their laptop. Not everybody has Matlab. So text files is something that you can email, right? You can do all kinds of stuff with text files. Okay, now, this worked actually, this save and load worked on text files, but I might have trouble because this load has certain expectations. Let's say that I tried to save both A and B into something called AB. I can type that file. You can actually see it in your directory as well. My directory is squished here, but here is a.t. So these are the files that I have just created. I can type it, and it actually just got dumped. So this is my A, this is my B. My Matlab does, or the text file, for instance, the difference is that the text file does not know that these are A and B stored in there. They're just numbers now, they're in text file. Yes?
Is there a simple way to format it to where, because it's like a double right now, I think, or is there a way to format it?
You could, but this simple save, so you need to go to a different command, not the command called save. It's called, and we're going to do formatted output, it's called fprintf, and we're going to use it a lot. Okay. So there is a way to format. Right now we're trying to figure out what can easy tools do. So if I try to load this, there will be a problem. Essentially, load of text files kind of grabs things into matrices, so it expects a matrix format, which this is not. Okay? I have missing numbers here for matrix format. So if I actually try to say data load, it's going to have issues. There's number of columns, and it has to be the same, which it's not, because it's expecting a matrix. So load works, load of text file expects a matrix. So essentially, this is where I actually need to have a more handle of how I read files. And this is where we can use that fopen, fclose, and fscanf. If you remember, Rahul went over it last week. So I'm going to exemplify it once again. So it gives you more control in reading. So now I actually have to go down to open file, read the data, close the file. Okay? So we're going to say, let's open the file and give it a tag or ID. So file ID is typically called FID. So I'm going to say open this ab.txt for reading. So this is where I have much more command. If I was going to format my output, I would open the file for writing. Okay? And then I would write to it and close it. So this is read. Then I'm going to say data. Just fscanf, so basically f at the beginning, it's for file scan, file print, file scan, file ID. And I'm just gonna say, well, find out those numbers. I'm gonna give it a number of G. You could also use F, which is a floating point number.
What's the percent
Oops.
GB?
FID. So that's the format. I'm telling it there are numbers in there. There could be also text. I could ask it to read in text.
So FI.
And there could be actually more formatting here in there. We're gonna get to printing it and then it's gonna be a little clearer. For now, just use G or F. %G or %F. Those are the real numbers. So I'm gonna store it as real numbers. If I wanted to force integers, then I would put D. But these are not printed as integers, so I don't wanna use that right now. Okay? So then I'm gonna say data, and now I actually see that my data, all of the numbers are just in one long column. Okay. And this is, so what is the size of this? This is a column vector that is 6 by 1. This is where I possibly, depending on what data is, I might want to use reshape to shape it differently. So knowing that these are two vectors, I might want to say, oh, well, my other data 2 or data 1 is reshape my data into, let's say that I want to have 3 by 2 because this is my first vector, this is my second vector. So this is where you kind of have to know what those numbers are. You have to talk to the engineer that wrote those numbers. And then you reshape it and possibly then I have 2 vectors. So I could say, A is my first column and B, data 1, and B is my second column. And now I go and do something with A and B. So if this was the real data coming from the field, it could be, oh, maybe I have porosity in there and water saturation, and now I go and compute something with that porosity and saturation and do my prediction. Okay? And one thing that I forgot to say is now that I read the data, I want to close the file so that there's no any corruption. Okay. So this is a brief review of how we save and load or read the data. Depending on how much control you have on the reading and writing process, you can use different types of commands. Okay? All right, so this was just a review. Sorry? I typed F close, file close, F close. F open, file open, F close, file close.
Could you scroll up a little bit?
Hmm?
Could you scroll up so like a couple lines?
Or I can re-execute them. This. So I was just saying, so my data 1.
What's the reshape part? Yeah.
Reshape
The data 1 you can reshape.
is this. So my data was a 6 by 1. As long as I have enough numbers, I have 6 numbers, so I can create a 3 by 2 table of it. And the way a reshape works, it goes down the column and takes as many. So if I'm saying 3, 2, first 3 numbers in the first column will be the first 3, and then the second 3 column-wise. Okay. So this was my data. So my data was this. So this first 3 is my first column, and then the second 3. So it goes first column until it can, and then second column and third column, it keeps going, as long as you have enough elements.
If you get a 0 for F close, F
That means that it closed correctly.
How did you type in A again? Did you type A equals to data 1 and
This is grabbing the first column of data.
What did you have after you reshaped it? You said data 1 or anything else
So data 1,
after the reshape?
so everybody in first column. So double dot stands for, colon rather, stands for everybody that fits in the criterion of being in first column. and reshape, basically takes a matrix and reshapes it into a new matrix. Ultimate number of elements has to match in both matrices for that to work. And the way it's doing, or the order it's working in, is taking the first column and it goes as many elements as it needs in the first column, then the second column, and so forth. Clear? Questions? All right. So this was essentially recap. Now let's move on. So we will actually get to plotting and graphics. Again, most data is not really useful if I just look at the table of numbers. Never gonna get anywhere. I have to process it somehow. So I either have to plot it and do a visual representation of what's happening, or summarize it into one or two numbers that I can work with. Okay? So essentially the way it works is if you just want a simple XY plot, you say plot whatever data you want on x-axis, and then y data is whatever data you want on y-axis. Okay? And of course, when plotting, you have to have the same numbers. So plot commands really plot points. So you have to have the pairs of x and y to actually plot this. And then you can specialize this plot in, you can give it different colors, you can rename the axes, you can do all of those things. So let's actually do examples. So I'm gonna create myself a vector, a very simple vector. Gonna say x is linspace, creates vectors between certain limits, so let's say 0 and 10, and I can tell it how many points I want. If I don't give it the number of points, it's gonna do 100. So there's a default value, but I'm gonna give it 11 points. So this is my x. And I'm gonna say y is 4 times, well, let's actually do something more complicated. X squared, so this is going to take every element. We're going to get to this in a moment, but I want to exercise it already. So this is actually going to take square of every element. So it's going to go element by element, and this dot tells it go element by element and square every element. So work on the entire x squared. Oh, minus 5.
But so we don't have to put the squared in parentheses and then minus 5, or would do that?
No, you know, this is going to be fine. No parentheses needed. You can, but no, not necessary.
It follows orders of operation, right?
Right. But you can't do, this is not x times x, because x is a vector. Right? So as a vector, it would try to use matrices. Okay? So I can't do it as x times x. Okay? Maybe I can do x times x prime. No, x prime times x. No, x is a row. Yeah, x times x prime. X prime would do it. But that would give me one number, and that's not it. That's not what I want. I want every element square element. So if I want element by element, I'm going to put a dot.
Okay. But if you wanted to do the matrix, you could just stop.
Yes, that's matrix multiplication. So I'm just going to then do plot xy. And with plot xy, it basically took all of those points and it just drew a line through them. So this is just the default behavior. Now if I wanted to tell it something else, well, I don't like blue, I'm gonna do red.
Really?
Then I'm gonna tell it R. Oh, maybe I don't like the line because line is actually fake because it's connecting points with a line. I can just say, well, no, just put stars. So these are my actual data points.
That's cool.
So some common numbers are red, R, G, B, K is black. You can also tell it what style of line. So I could have said, actually on top of this plot, or just do B dashed line, dashed blue line. So I'm gonna get this. You notice that every time I plot, the previous plot disappears. If I don't want it to disappear and I want to plot things on top of each other, I'm just gonna say, hold on. Quite literally, you gotta talk to your Matlab. Hold on. Hold on there, buddy. And then plot something else on top. If you wanted to stop doing that, you say hold off. So hold is a toggle that goes on and off.
Stop doing what? What's the function of hold down?
Hold off. Hold on just says hold on and put the next plot on top of each other. Do not create a new plot. Otherwise it wipes everything and starts new.
Oh.
This plotting figure. So for something to be plotted, it has to create the figure, give it some space, figure out where the axes are. Like all those things, the things that you don't see, you just create the figure. Right? It has to do all of those things, and it's going to do them fresh every time unless you tell it to stop refreshing.
So B is blue.
B is blue. So you can actually, Y is yellow.
Why is yellow?
So this is actually the
Black is okay.
pre-coded colors. Yellow, magenta, cyan, red, green, blue, white, and black. Not sure what would the point be of
White.
doing white on white, but you could do white on black. You can actually change the background. And then there are symbols that you could use. So there's a diamond, square, star, plus, X mark, and so forth, which is important when you have multiple types of data. And then your line could be solid, dotted, and dashed.
Wait, so if you use the triangles, would the triangle go like triangle?
Well, there's triangle to the up, down, left, and right. So you could orient your triangle in different ways. Let's give it a shot. Whoops, hi. Was it T? No, it wasn't T, was it? No, it was a we.
We? Oh, we.
I just have to now find my plot now. There we go. I just put things on top. This is where I should fold off. I drew things on top. And then it could also point down. There's a triangle pointing down. So you can play with that. All right. Now let's actually keep moving. And let's actually now do something with the axes as well and do a little more complicated. So I would like to plot multiple functions, include titles, legends, and all that stuff. So let's actually create ourselves. So how about you go and create these 4? So I changed X values, and this is by default going to do 100 points in between 0 and 3 because I didn't specify how many. So we're going to get much denser number of points in the interval. And then I'm going to create 2 exponential vectors. And I can plot both of them at the same time. So if I do plot xy1 and then xy2, it's gonna plot them both And if I don't specify anything, it's gonna make some default choices for me. And they look like this. So these are the two lines that it chose for me. So it chose two colors, reddish and bluish. It's not bright blue, it's not bright red. If I wanted to specify each of those lines, then I would say plot x, y, 1, and then all of the parameters that I want to describe that y. The first plot, and then the second one. If I wanted to do legend, I would say legend, first plot, again these numbers don't mean much, second plot, and it's having hard times with my requirement to have larger axes. I could say I could label x axis with x label. So I get a label x, and I could do y axis with y label. So you will get a y here. I could give my plot a title. So then I'm going to have an example plot here. I could also limit my x-axis. I realize that this is possibly too wide of a range, so I can just limit it between 1 and 2. So then I get a better view of values just between 1 and 2.
Wait, Professor?
Yes.
When you said plot x, x comma y1, x comma y2, that you plotted x twice?
Yeah, because I need x-axis for all of them. It could be x, could be actually something else, right? So when plotting, you need x-y pairs. Okay? So x-y1 is the first set of x-y pairs, x-y2 is the second set. So those are two separate plots then, yes.
What is that x-lim do you?
X-limit limits x-axis to range 1 to 2. Otherwise it was 0 to 3, because that was my data. So it figures out the axis by the span of the data. Now, all of those things, actually, you can find a way to manipulate from here. So you can put the toggle legend on and off. You can change some colors. Well, right now we don't have a color bar, so color bar doesn't mean much. But you can add color bar and things like those. The reason why I'm focusing on writing them down is that ultimately, when you're producing plots, let's say that you go to your manager and you need to present the data. And you present these plots, okay? And then he tells you, yeah, that's all great. Can you now do it for these other 3,000 rows? You want to automate that script. You want to type it in so that all you do is just read in this new data and execute all of the same make my plot nice commands at once. If you don't execute, if you don't know these command lines, then you have to go and click on everything yourself again. Whereas if you have the script, it's just going to execute the same as once you're done. You just read in this new 3,000 wells, present them in the same way, assuming the choice of the axis is correct. Maybe you need to fix it up a little. Again, you want something that can be automated. Automate, automate, automate. Okay? So this is why we're focusing on being able to tell. So for everything that you can click, on Matlab you can click quite a bit. So everything that you can click, you can also find the command for, because the moment you click, Matlab actually constructs a command and spits it out, and that's what's executed. Okay. So focus on having workflows that can be automated. All right. So basically, there was plotting here, and then there's certain operations. So you need functions to change the axis. You need axis, grid, gtext, legend, text, title, x label, y label. I exemplified some of these. The other ones you can play with yourself, but it's important to know that basically everything, you can modify everything. I could also, since this is exponential data, I could actually use log. So if I just wanted y-axis to be log scale, then I can say semi-log y and replot everything all the same. So let's give it a try. Semi-log y.
Oh, semi-log.
So here I'm just gonna say semi-log. And let's say that in the meantime, I really wanted some different colors. So let's try the cyan and yellow. And let's see what happens. Whoops.
Semi-log.
Log. Oh, why did I say plot?
Oh.
Semi-log y. Here it is. And here's a choice of color that you should never show to your manager. Most humans have really hard time reading yellow on top of white. Okay? So you will have everybody in your meeting squinting trying to read your plot. So do not use yellow. Okay? Again, it's a little hard to distinguish, and some people who are hard of seeing might have extreme difficulty reading this. Also, the people in the back of the room will have extreme difficulty reading this. Always use very large numbers so the person in the back of the room can read your plot, and use proper colors that can be distinguished. So yellow is a bad choice. It's cute, but it's a bad choice. Okay? You can also put grid on, and then you will have grid lines. That's important if you actually have to make certain decisions. So you need to know where certain lines are and where could be the cutoffs or thresholds that you need to apply. So give it a try. Grid on. I showed you how to limit x-axis with xlim, but you can actually modify all axes. If you just say axis, and then you put limits in x and limits in y after each other. And if it's a three-dimensional plot, you can actually continue and have two more for z. We're not, right now we're not plotting z.
Can you manage the steps that they take in between like the max and min to those axes? You know, like if it's
Yes, ticks, they're called ticks. So you can actually go either in the plot to modify what those are. I don't know from the top of my head what the command is for, but it's something to do with ticks. So you can, and then you can rename those ticks to be something other than numbers, if you will, things like that. So you can map them. You can do all kinds of advanced stuff. So pretty much everything you can think of, you can probably do it. The key is finding a way to do it. There is a visualization map in Matlab. It's something like a 200-page document that you can access, and it's from Matlab website. And especially 3D visualization can get really cool. Like if you have pressure fields, and like you can have velocity fields, pressure fields on top of each other, things like that, which can be really insightful for. And we're gonna get to 3D data. So again, if you can think of it, probably can be done. It's just you finding out the way to do it.
Wait, so Matlab can plot 3D?
Oh yeah. Oh yeah. You're gonna have fun time plotting 3D permeability. I see it in your future. It's on Friday.
Awesome.
There's new homework. There's new homework in the works.
Is that actual fun?
Yeah, it's total fun. It's porosity, permeability, cross-sectional plots of data. All right. Huh?
The grid on.
Grid on will just add grid, but do it. Just type it in. Don't ask me. Type it in. Grid on.
Go to your graphics.
And especially with log plots, you want grid on. Okay? Because it's hard to know where it's times 10 times 10 times 10. But it's not evenly spaced, so you won't probably. Then legend, you can give it a legend. You can also specify positions for the legend if you want to fully automate things. It could be in different corners, things like those. Again, I'm not going into all of the details. You can specify the font size. You do want large fonts most of the time. My plot was actually produced in a pretty large font because I have set defaults because I'm projecting stuff. I have much larger font than probably you do. So your font might scale with whatever you have set as a default. If you want to change it, then you use font size. And it's actually getting smarter about it. Literally last semester, that was Matlab 2015B that I had. I uploaded a new one. It wouldn't do that. Even though I had defaults with this very large font, every plot that I plot here in class, I had to change the font size. So things are changing as new edition of Matlab. There are certain defaults that happen. But if you need to change it, this is how.
Professor,
Yes?
when I type create a legend, it says like why.
So this 2, I think it's outdated. So put that position up. So the whatever it says, that's something that I noticed actually last time. So last 2 versions, just do this. Forget about the position. Position or the way positioning works has changed.
Okay.
Okay.
Oh no.
Now this is an assignment for you to work on here.
Here, cool.
Have 5 minutes. Create 100 points on a circle of radius 1 and plot that circle. So again, this is applying your calculus. So circle, I want these 100 points created. And remember, plot actually plots points. So it's going to connect them with a line, and that's how you plot circle. But you need to know mathematical formula that gives you x and y coordinates on a circle. There's a point here, x, y. Let's put some calculus to work. Parametrization of circle. And also once you plot it, I want a thick plot. People in the last row would not be able to see it unless you have a line width of 2. So you need to figure out how to do line width.
Professor,
Yes.
what is lin space points are random
No, it's equally spaced points.
equally spaced points?
Between where and where?
Between,
How do you parameterize a circle?
because I know I need to do from 0 to 5.
Is the angle. So create angle first. Between 0 and 2, 5. 100 points is enough. So do length space on that.
Okay.
And then knowing angle, how do I get x and y positions from that angle?
You do cosine of x.
Okay.
Yeah. Do
So x is cosine of angle.
what was the first number of lin space again?
Length space. So lower limit, upper limit number of points.
So lower limit, upper limit. So x. But I put 0 higher. How do you do x is 2
times pi.
Do I put 0 or just or 0 pi?
0, 2 times pi. So first thing that I need is points on a circle. How do I parameterize a circle? What's the formula?
Oh.
If my angle is theta, what was this point here? X is what? X is what? Cosine theta. And y is sine theta. So first I need a bunch of thetas, and then I'll easily compute x and y from those thetas, right? Yes? How do I get a bunch of thetas? The typical red shirts, you can more red shirts. Top red shirt up there. How do I pick thetas? How do I create equally spaced line space? Yes. So I'm gonna call it T is instead of theta. Line space between 0 and 2 pi, right? It so happens that pi is already in there, so I can just write pi, or I can write 3.14, it doesn't matter. And by default, I'm gonna get 100, and I'm good with that. So my next red shirt, how do I get x's and y's from this T? Next red shirt is ignoring me in the, right there. Yes, you. Hello. So how do I get x's? Can I just do cosine of t? Yeah, I can. So if I say x is equal to cosine of t, these are my x's. And my y is sine of t. And I'm gonna suppress the output. So now I have x and y's. I just plot them. Okay. In degrees? This is polar. Oh, then you would solve, but then I would have to do upper branch and lower branch. So it works. Okay? So the way you would do it is you would say x, or I'm gonna say x1 is line space -1 to 1. Okay? And your y1 is square root of 1 minus x1 times square. So square root of 1 minus x square. And then you plot x1, y1. Okay? But then you also have to say hold on and plot x1 minus y1 to give it a full circle. And then this is not a nice plot, so I have to also say axis equal to have actually a good proportion between x and y. And one more thing that I can do is I can say axis type. I want you to find out, Googling or otherwise, how to change line and bend to 2. Okay, this is line 21. All right, see you next time.